Uh, I've been speaking about the ways that batteries could produce much higher voltages, one or two orders of magnitude higher voltages, and this has to do with a way of perceiving that the um, electrical potential differences that are present between different atoms, which was a previous source of battery energy, and then comparing those with the energy that comes from piezoelectric materials, uh, which is much higher, hundreds of volts, thousands of volts sometimes, and that there's a region of possible atomic as well as molecular structurings between those two forms. Now, I know an actual physicist would point out that the electron potential of atoms is based on their nuclei, whereas the piezoelectricity has to do with the conformations of the electron orbitals around atoms in a crystal. Yet the fact that there's so much space between those two ideas suggests that there are many places between to create new energy sources. One approach that I won't say I described it because I just said a few words, is that I'd like people to think about percolation theory. Now, with percolation theory, the usual visual idea of that is if water is soaking through granules of material, there's a point at which it flows rather rapidly, and then there's a saturation point, and then if the geometry of the particles is of a certain kind, then the size of the space between the particles plus the viscosity of the fluid can be modified to create anisotropic effects. So when you think of a proton membrane, which is used at a thing with migrating protons to produce electricity, I think that along with the idea of there being an actual proton membrane, you could create a proton diffusion gradient similar to a percolation theory gradient, such that you created something different than a membrane. You'd create a porosity gradient which favored the movement of protons along certain anisotropic directions. Then, because we realize that piezoelectricity causes very high voltages, I think it's possible to create micro-patterned or nano-patterned, but possibly micro-patterned atomic structures such that protons really like to migrate a certain distance because of the percolation theory the geometry of where they are. The migration of protons, now with an ordinary proton membrane electricity producing structure, what happens is the protons move and then the electrons want to catch up with them, and then you use that to make electricity. The thing is, though, is that I think that you can get protons to move kind of near dielectrics so that the electrons are pooled together at a way that's different than a normal conductor. It's a little bit like a bunch of microcapacitors that sort of drain to a channel with a percolation theory proton environment, which has similarities to a membrane. Anyway, it's an approach to new kinds of batteries because now thinking about the piezoelectric effect, the piezoelectric effect uses physical change to move electrons around, whereas previous forms of batteries would use chemical change. Now, what we're looking at here is diffusional-based change, which just happens to be at the right size to be effective at the permeability area, the percolation theory-like geometric structure, which is reminiscent of a proton membrane. So there's this new idea of a diffusion functional battery, which is different than a chemical battery, which is different than a piezoelectric charge producer. I think this might work better if I drew pictures.